certified flight into known ice conditions, which of course is very important up here. So there's two enabling technologies that provide these capabilities. The first is this blown lift technology. And you can see that all these smaller electric motors along the leading edge of the wing blow the air both over the wing, but underneath the wing, and then it's deflected downward. So this aircraft has full span flaps that deploy to about 60 degrees of flaps. So it deflects all that air downwards, and you end up with what's called a jet flap. And that gives you a lot of control and a lot of lift at very low speeds. You might be thinking with 8 motors up there, you might be thinking that's like 8 Continental engines or 8 PT6s and all the maintenance and hassle and cost associated with that. But in fact, I would ask you to kind of rethink electric motors. Electric motors are very simple, one moving part, similar to a turbine, but they don't have the temperature, high temperatures that a turbine has. So there's none of this complicated fan blades, there's none of the high temperature or hot sections or HSIs or any of that. There's no really expensive, complicated overhaul. An overhaul is simply replacing 2 bearings. We expect an initial TBO in each motor at about 5,000 hours. And we think that will go, any new motor always has a lower TBO, and then that goes up over time. But we think the TBOs in these electric motors will be in the 10 to 20,000 hour range. And so having 8 motors isn't like having 8 PT6s on the wing or something. It should be very, very low maintenance, very low hassle. And you can have 2 guys take one of these, just lift the whole thing off the wing if you need to, and replace the whole thing as an LRU. So the props and the motors just come off together. Very simple to change out if there's a problem or a prop strike or anything. So the first technology is the blown lift. The second technology is the hybrid electric system. And so we've looked at hydrogen, we've looked at pure battery electric, and they both have pretty significant drawbacks in terms of either the technology readiness or the range capability. So the hybrid is really the technology that gives you the electric propulsion capability, but also gives you the range and endurance that you need for the distances up here in Alaska. The hybrid electric system is comprised, you see in the back, there's a turbo generator. It's a Safran Orano turbine tied to a generator. And there's actually 2 generators. Then there's a battery pack, which is actually 4 independent battery packs. And each battery pack is tied to 2 motors, 1 motor on each wing. So you actually have 4 independent propulsion systems, all fed by a single turbine system. And so if you lose the turbine, say on rotation, on takeoff, you have enough energy to fly about 15 minutes. So you can fly around the pattern and come back in and land again. Or if you lose one of the motors, say on takeoff, one of the benefits of electric motors is that you have incredible surge power with those. So on a turbine, you might get an extra 5% power. If you lose one turbine, you have another one as backup. In this case, you can surge them by about 40%. And that means if you lose a motor on takeoff, you will have the exact same amount of power with the remaining 6 motors as you do with the 8 motors that you had. So you actually don't lose any power on takeoff, even if you have a single motor failure. And the reason I mentioned 6 motors is if it fails one, the computer shuts down the one on the other side. So you always have symmetrical thrust. And then you have 6 motors that surge for about a minute max, which is enough time to climb out and then pull back the power once you're at altitude. So some pretty incredible things to think about. And while we're talking about operations up here, you can do some really interesting things with this hybrid electric configuration operationally. So you're decoupling the source of energy from the propulsor itself. So you don't have to have the propellers running all the time. So you can leave the turbine running, you can leave the climate control system running, you can leave all the avionics on, but shut off the propellers and load people on and off the aircraft while everything is still running inside the aircraft. So you can start thinking about operations like that. You could actually use this as a ground power unit and power some other stuff on the ground in a remote location if you needed to. There'll be some high voltage takeoffs on the aircraft if you needed to do that. So I digress a bit, but the point is there's a turbo generator, then there's a battery pack, and then there's multiple electric motors providing a high degree of redundancy and safety for operations in the aircraft. Just to give you an idea, the cabin is 460 cubic feet. A Grand Caravan EX is 340 cubic feet. The cargo pod is 110 cubic feet, so it's basically the cargo pod and the larger Caravan together in one single contiguous fuselage. It's not tapered, so the new Sky Courier is similar to this in that it's a straight fuselage, so you can load containers in there, you can load anything in there very, very simply, but plenty of room for cargo or passengers. There's also different configurations, so the 9-passenger, there's a door in the back, and then there's also another door up in the front left for any kind of combi. I know up here combi is a popular configuration, so you can put an air stair door right behind the pilot seat and then load and unload passengers separately from the cargo through the front that way. So very flexible in terms of how you can configure this, and you can reconfigure it on the leg out or the leg back, just depending on what kind of seats you have in there. So I would just kind of ask you to rethink what an airport really is. We traditionally think of an airport as a fairly large body of land, and I know here in Alaska there's all kinds of different airports, but this airplane really needs about the size of a soccer field or a football field to take off and land. So if you have some opportunities where maybe only a helicopter can get in today, or you can get a 180 in there and you'd like to carry 9 passengers instead of 4 or 5, this would be a great option for that. As well as just flying from regular airport to regular airport. This is our technology demonstrator aircraft that we're flying right now. It's about the size of a Cessna 182, and it's used to demonstrate these technologies at full scale. It's flying in Manassas, Virginia. And Peyton, if you could start the video, please. It's about a 2-minute video, and then I'll hand it off to Kevin.
But this is a solid approach that gets certifiable airplanes in the air, reducing carbon, saving time, saving money.
Our hope is that we can use these new technologies to democratize aviation and access to, not only the big cities, but also the rural communities and regionally.
There's a number of things that this airplane can do that will really make a difference. An airplane that can land and take off in soccer field-sized spaces, that's gonna be a game changer.
There's really 2 things that are unique about this aircraft. The first is that it uses distributed electric propulsion to generate a blown lift effect and is able to fly at really slow speeds. And the second is that it uses hybrid electric propulsion so you can get useful ranges.
Stand by. Ready taxi, props clear, throttle idle, brake release. Looks good.
Electra 1 and 2, runway 34 right, clear for takeoff.
I was so happy to see those wheels off. I think I was off the ground myself.
Response is actually really good.
Great engineers, great maintenance technicians. I mean, everybody's phenomenal, and the work they did, I was completely confident in. So I had no concerns. I knew the airplane would work, and I knew the systems would function as they were designed to do, and they did. As you slow down in a normal airplane, the airflow starts to separate, it starts to get disturbed and slow, and so the airplane gets very sluggish. This thing doesn't do that. In an electric airplane, they're phenomenally smooth, they're amazingly quiet, and the power is instantaneous.
So the goal from here, this is the first step on a long road. We'll continue testing this technology demonstrator at the same time that we're building a 9-seat prototype of what will be the first product airplane.
The realization of a dream. It's been 3 years of really hard work to get to this point, and there's certainly more to go, but at the same time, we've made a huge step forward, both for Electra and also for society as a whole. With the first flight of a hybrid electric short takeoff and landing airplane, we're on our way, onward and upward.
So thank you very much. I'm happy to answer questions when we get to the Q&A portion. Kevin?
Great, thank you. And to begin, you queue up the video that we sent over. So while it gets queued up, this is the Ampaire video, so wonderful. And audio?
Today was a monumental day for Ampaire, for ARPA-E, and for the state of Alaska and the progress of our industry. We finished a record-breaking flight program from Southern California, passing up through the states, crossing through Canada, and landing at the Fairbanks International Airport today.
Ampaire has been a project that we've supported for about 7 years now, and we've been supporting the efforts by using their aircraft as a test platform for some of our programs. And using the Ampaire test platform allows us to now demonstrate the capabilities of these advanced electronics.
It was really pretty special to be able to get off of the Alaska Airlines jet there at the Fairbanks International Airport and to literally just go down the runway and see the electric eel.
This is a twin-engine, half-combustion, half-electric aircraft that is able to fly over 1,000 miles in a single hop.
What Ampaire have done, they've taken their plane from Southern California by a number of stops up through the United States, through Canada, Yukon, and finally here to Fairbanks, Alaska. It is the longest hybrid electric aircraft flight in history. That's what makes it really special. So we're ultra excited about that. It's extremely exciting, and it's also a fantastic demonstration of their technology and its capability.
Alaskans fly more than anybody else in the country. Per capita, there are more small aircraft pilots in Alaska than anywhere else. And it's not just because we like to fly, it's because we have to fly. Over 80% of our communities are not connected by road. We travel by air, and it's small airplanes. Sometimes it's jet service with Alaska Airlines, but more often than not, it's smaller aircraft.
Alaska is one of the most challenging areas in terms of being able to demonstrate hybrid electric aircraft. If this can happen in Alaska, it shows that it can also happen everywhere else in the US as well as in the world.
Great, so that captured a moment last August where we flew our hybrid electric Cessna Skymaster from Southern California up to Fairbanks. Since then, we demonstrated a 12-hour endurance flight on our hybrid electric system, landing with 2 hours of additional energy reserves. It was a 1,400-mile flight, longer than a standard Skymaster could fly. We deployed through the remoteness of the Yukon without having to charge, because our systems, like a Toyota Prius, don't need any new infrastructure. We were able to divert 300 miles when Fairbanks was completely blocked in by clouds and by rain, and fly back into our origin airport, and then try again the next clear sky. Because being able to divert to any new airport and being able to divert a very long range is required if you're actually going to be operating a plane in the real world. And so we've been flying these Skymasters since 2019, but we've also been flying our Cessna Grand Caravan in Southern California. So think, what would you do if your Caravan or your Twin Otter or your King Air burned 50% less fuel and didn't have as high or had a lower single engine out risk? Like, what would that mean for your operations? What would that mean for your customers, for the economics, for the service and frequency that you're able to provide service to communities around the state? So that's exactly what we're trying to bring with Ampaire, is we're trying to bring lower cost aircraft to the communities that need them most by upgrading their engines. We're not just talking about it, we're doing it. The Cessna Grand Caravan is going to be a phenomenal launch product. I really can't wait till we make a similar video like this one, but with the Caravan instead. We're working with the US Air Force on our King Air programs. We've worked with NASA on the Twin Otter program. We've worked with OEMs on planes up to 50 passengers and have designs for planes even larger than that. So anywhere that planes currently fly today, anyone who currently relies upon them, we're just going to make those economics even better. We're going to make the service even better. We're going to improve the safety. We're going to probably move away from avgas and make everything nicely on Jet A as well, and hopefully do a lot of good for the communities around here. When you think about new technologies, you can think about the technology or the risks, but I highly recommend thinking about 4 different categories of factors to keep in mind. Number 1 is the technology. Number 2 is the infrastructure. Number 3 is the application. And number 4 is the safety. So technology, is it real technology that exists today? Or is it a really cool science project for the future? For infrastructure, are you using the infrastructure that you rely on today? Or do you need millions, billions, or trillions of dollars of investment in that infrastructure before you can operate? I recommend using the infrastructure that exists today. Applicability. Are they the planes that you fly today, on the routes that you fly today, on the people who rely upon you today? Or is it a system which might need completely new use cases to be built up, which is an amazing future that we support, but certainly will take a bit more time for implementation. And then finally on safety. Are you willing to take the risk on new technology? I've just heard stories about new avionics technologies and the growing pains of adopting that. So what if you could rely both on the new technology and get all those benefits, but also have the safety to fall back on systems that you know and trust, so that you don't have to put yourself or your family or your customers or your businesses at risk? That's the benefit of a hybrid electric system. Technology exists today. The infrastructure is what we already use. No plugs required if they aren't there. The applications are broad. Our propulsion systems do everything from the Mixmaster all the way up to the large ATRs. And the safety is unquestionable. So think about those things, and over the coming years, I'm really looking forward to working with you all and bringing great technology up to market here.
I'm going to walk and talk, otherwise I'll be reading my notes. So I'm Fiona, and as you may guess from my accent, I'm not from the US. I actually live in Seattle. I'm not Australian, I'm British originally. And my background is actually with Rolls-Royce, Parker Aerospace, and Boeing, before I joined Zero Avia. And over the years, I've watched as the jet engine technologies have advanced and improved their fuel efficiency and reduced emissions. In fact, I even led a retrofit fuel burn improvement package for the 777. And what's become really apparent to me is just how much that technology is limited in the face of the current climate crisis. And I'm really thrilled to be able to work in this space because my undergraduate degree is actually in biology. And so I've always felt at odds. I love the environment, I love aerospace. How can we bring the two together? And hydrogen electric is the ultimate solution that enables aviation to continue and actually protects our planet. So I'm going to approach the presentation slightly differently today. Oh, I don't have the slide advancer. So let's talk about the problem. So today, aviation actually contributes about between 5 and 10% of the global climate impact. And that number is actually set to grow significantly. In fact, it's going to double by 2050 with the increased demand that we've got for air travel. And as other industries decarbonize, it's going to have a massive impact on our contribution. In fact, by 2050, we are set to contribute more than a quarter of global carbon emissions. Now, when it comes to sustainable aviation, people often focus on carbon dioxide, but actually a lot of the climate impact comes from other emissions as well. And so we need solutions that tackle all of it. And hydrogen electric is the ultimate long-term solution for tackling all of it. It's not net zero, it's zero. The only byproduct is water. So our company was actually founded by Val Mifkatov, and hopefully I've pronounced that correctly. I'm sure Kevin will correct me if I got that wrong. And he actually himself was a pilot, very, very passionate pilot, And he actually was responsible for a lot of the software that enabled the electric charging network, particularly in California. And so he decided that he wanted to turn his attention to what he could do to make the aviation sector more sustainable. And so he looked at all the different technologies. And if we start at the bottom, hybrid electric, tons of benefits in terms of adopting it. Not going to argue, we need all of it. But it does actually have a limited environmental impact because you're still burning jet fuel. And then if you look at sustainable aviation fuels, yep, that's a good solution and we absolutely need it, particularly for the larger aircraft. But again, it's limited because we don't have the feedstock to produce it in the quantities that we need, and the price is set to soar. I attended Boeing's Sustainable Aviation Together Summit in May last year, and they talked about the fact that if we're going to go SAF, the cost is going to increase. And it's not the same for hydrogen. Hydrogen combustion, we're seeing a lot of work on that now, particularly with Airbus. Again, we'll definitely need it for the larger aircraft, but ultimately, it's not as energy efficient as hydrogen electric, and you've still got the nitrous gases as well. So hydrogen electric is the most environmentally friendly, economically suitable, and scalable technology that we've got. So how does it work? Well, we store the hydrogen aboard the aircraft, and if you want to talk the details of that, we can have a side conversation later. And basically what we do is we pass hydrogen and water across the fuel cell, and that is what generates the electricity that drives the powertrain. And as I mentioned, the only byproduct is water. Now, because you don't have the same temperatures and pressures that you have in a conventional engine, it means that the engine can actually stay on wing for a lot longer, and there is reduced maintenance costs. And because of the energy density of hydrogen, you don't have to actually carry as much fuel. Now, we're going to enter the market through retrofit to begin with. We're also going to be retrofitting the Grand Caravan. And so that's going to be our entry point. And then, we're already in discussions about what line fit's going to look like, what other products we're going to scale this technology to. Now, this is the initial technology, and the TRL level is actually pretty high because we're using a lot of automotive technologies in the first engine so that we can get it flying. We can actually gain adoption in the marketplace as people understand that this technology works, and we've addressed a lot of the concerns. And then as we scale the technology through the use of liquid hydrogen and high temperature fuel cells, you're then able to actually increase your payload because the weight comes down significantly, and you can travel much further. And so today we're already working on our ZA2000 that is going to power the 30 to 90 seat aircraft. We're talking with ATR, we're talking with de Havilland for their Dash 8. And then ultimately, we're going to go beyond the ZA2000 to the ZA10000. And that's when we'll be able to start powering regional jets and ultimately the narrow body. So we know that the technology is there. It's just going to, and by the next decade, we will be able to power narrow bodies. So our progress has really accelerated this past decade. In this decade. So in 2020, that's when we did our first flight. That was our 250 kilowatt engine. And then in 2023, got delayed quite a bit because, the weather in England's a bit of an issue. But that's when we actually took to the skies with our ZA600. And we've now completed a flight test program. So 10 flights, showing excellent progress, and we've seen what we expected to see with the engine, and we've now submitted further proposals for additional flight testing. So you're going to see more of that happening this year and next year. And next year you'll see the technology flying in a caravan. We also have a Dash 8 in Seattle, because Alaska Airlines is one of our partners, one of our investors, and they donated a Dash 8 to us. We're currently retrofitting that with the ZA2000 technology, so we can start doing ground testing towards the end of 2024. Now, Kevin got me a little bit earlier. I'm just kidding. Yes, I know what is at the top of everybody's minds: hydrogen infrastructure. At Zero Avia, we're not just developing hydrogen electric powertrains. We are developing the infrastructure as well. Now, I'm sure most of you in this room have heard about the IRA's hydrogen infrastructure bill. There's $8 billion going into that right now. And yeah, we absolutely need that to scale this technology in the long term. We need sector coupling. We need lots of different industries to be looking at hydrogen to really scale this to what's possible. But we're working with lots of different groups and internally to show how we can get hydrogen to the operators and how we can work with airports so that they can produce hydrogen and ultimately in the long run potentially sell that hydrogen and it becomes a revenue stream for them. So there's two ways that we're looking at. One is centralized hydrogen production and distribution, essentially where you truck the hydrogen to where it's needed. And that is what we would do in the initial days of deploying the technology. And yes, I am in discussions with the hydrogen infrastructure team about what we're going to do when there's diversions. We're going to make sure that that hydrogen is strategically placed so that there is limited impact. But we are also working with airports to develop on-site production. In fact, Zero Avia produces its own hydrogen on-site. So we have it in our UK facility, we have it in our US facility in Hollister, and we're building a big hydrogen infrastructure in Seattle right now. And so, we have solar panels so we can sustainably produce the hydrogen. We have the electrolyzers. We've got it to the aircraft both via a refueling truck, and we developed a pipeline that could actually pipe it out to the aircraft as well. So we are proving the technology ourselves. In terms of partners, this year we completed our Series C funding, 116 million. And we've got some great backers. Most of you will have heard that we're working with Airbus. But we've got lots and lots of great partners in the infrastructure space, in the airframe space. We've got some great customers. This technology is happening. This technology is proven. It's really a case of political and industry will. And wouldn't it be a shame if the technology was there, but we didn't set up the ecosystem to actually embed this? Let's not put a Band-Aid on making aviation sustainable. Let's get to the ultimate solution. Now, since everybody else has had a fancy video, I'm going to have one too, and then we'll sit down and be ready for your questions.
Most people.
All right, well, we're running out of time already. I had a bunch of questions, but so I'm going to hit a couple and then give John an opportunity to speak. But specifically, each one of you has identified your entry point. You've all mentioned the size of your aircraft. So my question is, why that size of aircraft? So the Cessna Caravan or the 9-seat, and then why Alaska? So we'll start, Kevin, and then we'll have each of you.
So, so there are a few reasons to start with the Cessna Grand Caravan. One, people rely upon it. Two, it's got great capability already, and people trust it. Three, beginning with an existing aircraft, we thought was important, and focusing in on a single challenge, which is the upgrade of an engine, and not the novel challenge of higher or different performance of the aircraft type itself. The reason to start in the Part 23 aircraft category is because that's where regulatory approvals are ready for new propulsion types. Part 25, not yet, though they will get there eventually. And then finally, from the technology standpoint, when you're looking at the capability of lithium-ion batteries or the electric motors or the power electronics that support it, all that technology is capable of powering aircraft in this turboprop class, especially in the Part 23. And so there are no bottlenecks between us and getting a reliable system out there that otherwise, if you're going up to the megawatt class plus, there's still some science that needs to be done to really get those product ready. So that's why Cessna Grand Caravan, King Airs, Twin Otters is absolutely the right place that we decided to start with. And then the Skymaster, because I mean, who wouldn't want to fly a Skymaster?
Thanks, Kevin. So right now we have letters of intent for letters of interest for over 2,000 aircraft across 42 different customers, and most of our customers are Part 135 operators in the US, Brazil, Europe, all around the world. And for most of the world, at least the US is the largest market, 9 seats for the most part is kind of the limit. So that's really the sweet spot for bringing a new aircraft to market. And by the way, if you couldn't tell, our aircraft is a clean sheet design. We're taking a bit of a different approach than Ampaire, who's doing retrofitting existing aircraft. We think that, and there's plus and minuses to both approaches. No one approach is the right approach. It just depends on what you want out of it. And the way to really optimize for these new powertrains and the location of where all the parts go and the weight distribution and the optimizing for the new capabilities that electric propulsion gives us, we think a clean sheet design is the way to go. So, and as Kevin said, starting out in, say, a Part 25 aircraft that costs a few $1 billion to develop is a big ask for any startup company, for any company. So this technology is naturally going to start out where it can happen for kind of the lowest cost and the quickest way to do it, and that's the Part 23 market. So we start out with experimental, then we have certified Part 23 aircraft, then who knows where we go from there. We think Alaska is just a great market for the type of aircraft that I showed you. There's really a need for that type of aircraft in this market. But in general, if we can make an aircraft that can operate in Alaska in the rough terrain, in the hugely varied weather conditions and the distances that need to be traveled, I think that aircraft could be successful anywhere in the world. So Alaska is really a great market to build the aircraft for, because it represents a broader opportunity. Yes, sir.
What are your, in making the jump to Part 25 aircraft, what are the certification challenges that you're going to have? Currently, what's your biggest certification challenge now? And then what will it be when you make the jump to Part 25?
So the question is, what's the biggest challenge we have right now in certification, and then what's the biggest challenge in Part 25? And we could talk all day about that, so I'll give you a really abbreviated answer, apologies. But so our aircraft is a fixed wing aircraft. It's a very well-known aircraft to the FAA and to EASA and Transport Canada and ANAC and other regulators. So that part of it is very straightforward. We're not pushing the envelope too far. The new component of it is the propulsion. So the electric motors and the batteries and the whole hybrid system as well. Our aircraft is going to be one of the first Part 23 fly-by-wire aircraft. And that technology is very well understood in the Part 25 space. Companies like Honeywell, Safran, Thales, and others have taken the technology they've developed in the Part 25 aircraft and sort of reimagined it for Part 23 aircraft. So that's not going to be a big hurdle. That's a well-known thing. When you get into Part 25, there's all kinds of standards that get much higher, much more difficult. Basically the stuff when you have critical failures, catastrophic failures, right? There has to be much less chance of those happening, and that flows through all the different systems, and you end up with a lot more expensive systems, more complex systems, and we could talk all day about that. But the point is, the cost to bring that aircraft to market is a lot higher, and you physically usually have a much bigger aircraft, so that costs more as well. So the best place to start is in the Part 23 space.
Mark 25 airplane, are you, say like we wanted to be able to replace the engines with a CRK 700 back on it, which, you know, there's no clear replacement based on the scope laws of the US to be able to do that. Would you, right now, is it a matter of power generation? That type of airplane?
Well, maybe Kevin, you want to answer the retrofit question.
Yeah, if we can wait 1 second on that, I want to give Fiona an opportunity to mention why the Caravan in Alaska, and also John an opportunity spot. Then we'll have a few minutes for questions, but we are running a little short on time. So go ahead, Fiona.
Thank you. The Caravan is a high-wing aircraft, so that gives us more opportunities with where we can put the engine and store the fuel. But also we're focusing on it because we know that with the hydrogen, scaling it to larger aircraft is going to take a little bit longer, and we want to start having that impact on the environment now. We appreciate that it will be small in comparison to the larger aircraft, but it's it will enable the industry to start to adopt and build trust in our technology. Why Alaska? Well, after last night, I would say because you guys are awesome, super friendly. For my first time visiting, and I'm loving it. But there's a lot of work being done in Alaska to look at sustainable energy production. There's the big project with the Port of Alaska, and there's various other projects. And so to have green hydrogen now is the time to start integrating with the sustainable energy that's being deployed, get involved in those projects. And we think that that Alaska is just a great region where we can have a bigger impact than just an environmental impact, but the social impact here too.
Thank you. We are running short, so I'm just going to talk with John. Okay. One of the questions I do have for each of these before I get to John on this is Alaska. What are there any barriers to entry to the state of Alaska for your product type and your technologies as of right now? You know, if we want to adopt your technologies into our route networks and everything like that, what are the challenges for each of your products as of today, and how will they evolve?
I think -45, -50 degree temperatures are pretty scary, and though we've brought a plane up here already and flown it around, I think that there's still more work to be done with the Arctic Energy Office and others as we go through making sure that our planes are prepared for that level of ruggedness. I mean, the Caravans are already good. There's some icing, flown in known icing issues, people prefer not to, but like it's a good plane, it's standard. We'll be able to meet all those same performance requirements. Temperature is really the thing, I think, up here that's going to be most challenging for our product.
Yeah, our goal is to develop a plane that would drop into the way you operate today. I'm sure there's going to be some devil in the details on that, but that's our goal. We don't want you to have to build any new infrastructure, to have new fuels, new anything different. It just fits in. You take an old plane out, put a new plane in, and you can operate, hopefully, make more money with the new plane. You have higher reliability, and opens up some new route opportunities for you. So that's our goal.
So I've already spoken about the infrastructure challenge and what we're doing about it. I would say that one of the big things for all of these technologies is education. These technologies are different to what people are used to, and we need to make sure that people are educated in the facts and why this technology is going to be successful and help to overcome people's concerns. And then another issue that I see is obviously if you're retrofitting aircraft, then there's a cost involved. And so if there's a way that we can work with local governments to look at how we can help offset some of those costs, that's very helpful. But Zero Avia is committed to finding commercially viable solutions with whoever we work with. But certainly wouldn't help to have some extra money from the government.
And then I wanted to ask John about insurance, because every single one of us pays a pretty big bill every year. And so John, with these new technologies, is there any concern there? Is there going to be a limitation to the number of carriers willing to insure the hulls and liability for something like this? Because ultimately we'd like to allow Bob Richmond to be able to retire here soon instead of having to keep paying him.
Yeah, I mean, believe it or not, there actually is support within the carrier community for these types of emerging technologies. I mean, I think that the insurance companies realize that this is the future of aviation and it's their duty to support innovation and not stifle it. So believe it or not, there are carriers out there that have specific teams that work on emerging risks and emerging technology. And really the key is collaboration. I mean, education, as Fiona mentioned too. Public acceptance is going to be a huge key for underwriters to understand what's actually going on with these technologies. And I mean, broadly speaking too, there is actually quite a bit of support for Alaska aviation in the insurance community at the moment. I'm happy to speak with individuals about that going forward, but we're not having to go to London to complete programs anymore. There's support for the limits that are being put forth that you are required for your operations. And just in general, there's kind of a different light being shed on Alaska at the moment. So it's kind of a focus area for underwriters. And it's definitely an area that is trending in the positive direction. I know we've had a tough couple of years in the insurance space, but there is light.
Great. I have a bunch more questions, but I'll let all of you ask them individually as we get moving on. Does anybody have, we can take one or two questions before we end it, and then you can all meet individually. Right.
Yes, and it would be for the Caravan, because I mean, the Skymaster is a phenomenal test bed, but unlikely to be a near-term product. Caravan's much more useful, we think. And so our cold weather tests will be on the underlying technologies, which is really where the risk lies, less so in the integration on the airplane, but then also once integrated into the aircraft, absolutely doing those cold weather tests.
All right, great. Bob.
One second, so that people online can hear.
I just wondered how the brokers involved and what context do you have? What's the discussion about how you get to the per seat limits that we see today here in Alaska?
Yeah, that's a good question. I know that's been a focus area for insurance underwriters for a long time. Realistically, underwriters are concerned about the maximum loss that they're going to pay out. So by limiting per seat, that kind of limits their exposure to any potential loss. Unfortunately, I think the era of smooth limits is going away. Or if it's not already gone, a lot of the per seat limit maximums that we're seeing are about $1 million a seat, and that's really all that we're, that's really about as high as we're able to go. There are certainly some exceptions for loss profiles that are clean, but I think that after the last couple of years, we've certainly seen challenges in the large losses that have been paid out. That being said, that's your broker's responsibility and our responsibility to advocate on your behalf. And we can certainly put programs together, and we have put many programs together with $1 million per seat limits.
And so the problem I see in it, and I know Dan isn't worried about this, is you have a 150 per seat limit. You put a plane out there in Lake Hood, and the medical bills of the people who are injured are, all over 150,000. So the defense attorney continues to get paid. I know that bothers Dan, but that's the way the system works. But the problem is the owner is kept in that lawsuit because the plaintiff's lawyer said, I can't make any money. on 150 per seat limit if the medical bills are over that. And so these lawsuits tend to drag on with people trying to pierce the corporate veil and go after the 135 carrier or the operator of that, the service out at Lake Hood. So I just see it as a real problem. I think the underwriters feel they're protecting themselves, but at the end of the day, of course, their assured gets stuck in this lawsuit. Admittedly, they have an attorney to protect them, but it drags it on and on and on because the limits are so low. Whereas if you got them up to 500,000, which they used to be, we could settle those cases. And now I realize you probably can't do much about that, John, but that's a thought, yeah.
Well, so actually, to your point, I think 150 per seat is considered to be quite low, and we've experienced that underwriters are willing to go up to $1 million per seat in a lot of cases. Either way, you're going to probably face that challenge because of the way that social inflation is driving up the costs of losses everywhere, not just in aviation. But it is the insurance company's duty to defend you in a suit, and defense costs are outside of that, the limits that are provided on the policy. So, unfortunately, probably going to run into that regardless of what your per seat limit is. But that being said, there are higher per seat limits available in the market.
Thanks, Bob, for hijacking it. Joking. I do encourage each of you to have some conversations with each of the representatives up here, because I'm not the greatest example of I drive a diesel GMC truck, so I'm not the cleanest guy in the world. But to be honest, this is where we're going, and we are seeing a pretty interesting time when it comes to we're going away from the tried and true turbine and recip, it seems like, at some point in the future, and our size aircraft is going to be the entry point for that. So learning about it now, getting familiar with it, is probably the more responsible thing as business people and air carriers within the state. So I do encourage you to spend some time with each and every one. Thank you.